and welcome to the Atmosphere Show. We hope you enjoy our final show of the four-part series about the layers of the atmosphere. On today's show, we will be talking about the thermosphere.
The thermosphere is a layer of Earth's atmosphere. The thermosphere is directly above the mesosphere, and it extends from about 90 kilometers, or 56 miles, to between 500 and 1,000 kilometers above Earth.
The boundary between the thermosphere and the exosphere above it is called the thermopause. At the bottom of the thermosphere is the mesopause, a boundary between the thermosphere and the mesosphere.
Temperatures climb sharply in the lower thermosphere, below 200 to 300 kilometers in altitude. The level will often hold fairly steady, with increasing altitude above that height. Solar activity strongly influences temperature in the thermosphere. The thermosphere is typically about 360 degrees Fahrenheit hotter in the daytime than at night, and roughly 900 degrees Fahrenheit hotter when the sun is very active than at other times. Temperatures in the upper thermosphere can range from about 932 degrees Fahrenheit to 3,632 degrees Fahrenheit or higher.
The boundary between the thermosphere and space above it is called the thermopause. At the bottom of the thermosphere is the mesopause, and the boundary between the thermosphere and the mesosphere below.
Although the thermosphere is considered part of Earth's atmosphere, the air density is so low, this layer, that most of the thermosphere is that we normally think of as outer space. In fact, the most common definition says that space begins at 100 kilometers, or 62 miles, slightly above the mesopause. At the bottom of the thermosphere, the Space Shuttle and the International Space Station both orbit Earth within the thermosphere. Much of the X-ray and UV radiation from the sun is absorbed in the thermosphere. When the sun is very active and emitting more high-energy radiation, the thermosphere gets hotter and expands, or puffs up. Because of this, the height of the top of the thermosphere, the thermopause, varies.
Below the thermosphere, gases made of different types of atoms and molecules are thoroughly mixed together by turbulence in the atmosphere. Air in the lower atmosphere is mainly composed of a familiar layer of about 80% nitrogen molecules and about 20% oxygen molecules. In the thermosphere and above, gas particles collide so infrequently that the gases become somewhat separated based on the type of chemical elements they contain. Energetic ultraviolet and X-ray photons from the sun also break apart molecules in the thermosphere. In the upper thermosphere, atomic oxygen, atomic nitrogen, and helium are the main components of air.
Much of the X-ray and UV radiation from the sun is absorbed in the thermosphere. When the sun is very active and emitting more high-energy radiation, the thermosphere gets hotter and expands, or puffs up. Because of this, the height of the top of the thermosphere, the thermopause, varies.
The thermopause is found at an altitude between 500 kilometers and 1,000 kilometers or higher. Since many satellites orbit within the thermosphere, changes in density of the very, very thin air at orbital altitudes brought on by heating and expansion of the thermosphere generates a drag force on satellites. Engineers must occasionally take this varying drag into account when calculating orbits, and satellites occasionally need to be boosted higher to offset the effects of the drag force. High-energy solar photons also tear electrons away from gas particles in the thermosphere, creating electrically charged ions of atoms and molecules. Earth's ionosphere, composed of several regions of ionized particles in the atmosphere, overlaps and shares the same space with electrically neutral thermosphere.
Like the oceans, Earth's atmosphere has waves and tides within it. These waves and tides help move energy around within the atmosphere, including the thermosphere. Winds and the overall circulation in the thermosphere are largely driven by these tides and waves. Moving ions dragged along by collisions with the electrically charged neutral gas produce powerful electric currents in some parts of the thermosphere.
Finally, the aurora, the southern and northern lights, primarily occur in the thermosphere. Charged particles, electrons, protons, and other ions from space collide with atoms and molecules in the thermosphere at higher latitudes, exciting them into higher energy states. Those atoms and molecules share this excess energy by emitting photons of light, which we see as colorful auroral displays.
Well, that wraps up our show for tonight and for good. We've decided to go into early retirement because Bill Nye and other science shows have taken all of our viewers. Thanks for watching for those few of you who do. Good night forever.